In this video, I will be discussing normal maps, which are used to create details and depth on the surface of your models. Now, problem with trying to explain normal maps is that they can be a little complicated to explain exactly what it is they're doing from the start. So whenever I teach this subject, I always like to start with bump maps. Bump maps use a range of values from dark to light to create the feeling of indentations, bumps, and crevices across the surface of your model. The dark areas poke in, the light areas poke out. If you're having trouble visualizing what that means, think about a topological map of the Earth. Here you can see where all the light pieces right here, the light spaces, this is a mountain range right here. The dark areas are the oceans that stick in. The darker is the deepest area, the light is the highest area. Now let's see what effect that has in Maya on a 3D model. Let's take a look at just a regular plane. And on this, I have placed a bump map. If I press 6, I can see what that looks like. And here we see a series of stepped increases, like a stepped pyramid, going from the lowest to the highest. This has no effect on the shape of the model itself. It's still a completely flat object. It just creates the appearance of a stepped pyramid. So let's take a look at the image that I'm using to create this effect in Photoshop. There we go. Dark to light. There's a gradual increase in the value as you get close to the center. I could have this blurred to get a smoother result, but I'm using these steps in order to exaggerate exactly what's going on. And so let me show you what a graph of this would look like if you graph out the value as we go across the image. Now, this is from dark to light. If you assume the darkest is 0, the brightest is 1, black to white, 0 to 1. And each one is stepping up by 0.1 as we go. So let's take a look and see what that looks like. Through the dark, step up, step up, step up, all the way up to the top. Now, if we were to take a look and see in Maya, what would it look like if we used a normal map instead? Say, this image here, this the normal map version of the bump map. What that looks like is this. Still the same effect. Not that big of a difference, I'll be honest with you. If anything, this might be slightly more exaggerated. But usually what happens is the initial bump map is too exaggerated. And the normal map tends to be a bit more subtle and creates a better look. Now, I've always been a bit confused myself for many, many years why people use normal maps instead of bump maps. I was aware that normal maps were in some way better, and they tend to have better detail, but I never understood why there's any real difference between them. So, let me try to explain what is that's happening with a normal map. Now, with the bump map, it was just value, dark to light. With a normal map, you can see that it is mostly this sort of bluish color, periwinkle, let's call it. But then on certain spots, there are areas that are less blue, less blue or more blue, areas that are purplish or greenish, and that's the only real difference. There's no gradual increase in depth. Because what's happening is this does not show you depth. This shows you the angle of the surface. In my previous video, I talked about how normals are just the lines that are pointing out of the surface to indicate this is a straight line out of the surface. That's the direction the surface is pointing. But normal maps take those lines and bend them. They tilt them. So let me show you what I'm talking about. Most of these surfaces are this periwinkle color right here. If I were to grab a copy of this color, and show what that looks like, you can see this the RGB values. And the RGB values go from 0 to 255. And you can see the red, green, and blue. The red and green are both 127. That's about midway between 0 and 255. What this means is this is the angle that the normals are pointing. This is their vector direction from the surface. And RGB is equivalent to X, Y, and Z. Z is pointing straight out of the surface. So 255 just means it is completely straight out of the surface. And the R and G, the X and Y, these are flat. So when it is this color, the surface is flat. It's completely horizontal to the shape of the object. However, if we change that color to being, say, less red than it was before, this is going down in the value right here. Let's ignore blue for the time being. Blue is also, the z-axis is tilting as well. We'll just ignore that and focus on the red and green ones and say that this is tilting up in the X direction, the red. And when it tilts down, the red value goes up and the X direction tilts down. If you want to make it more extreme, you can tilt it up a lot. And you can see that the red value has gone all the way down to 0. That is like the maximum, shooting straight up. When I tilt it down, shoop, all the way down, now is at 255. So when I look at my ziggurat normal right here, my step pyramid normal right here, it is flat, then it tilts up, flat, tilts up, flat, tilts up, all the way up until the top, and then it starts tilting down, flat, tilting down. If I look at the graph of that, we've got the colors here as well. The flat is that periwinkle. Tilting up is this bluish one, then periwinkle, then blue, periwinkle, blue, all the way along. Look at the top, and then pink, periwinkle, all the way back down to the base. That is what's happening here. Now, what is the advantage of doing it this way instead of this way? Why is this better than this? Well, let's say, for instance, I wanted to take this that I already had right here and make a little pointy bit at the top. This peak shape right there. How would I do that with the bump map? Well, here's the thing. The bump map goes from black to white, 0 to 1. It cannot go higher than it already is. If I want to make something else on top of this right here, I can't just stick this on top of it and have more than one, brighter than white. I would have to take the entire graph I've got right here, shrink it down, and then throw something else on top of that. And the problem with doing that is there's really not much left. Even if I shrink this down a bunch, there's not much room left for the peak. And you can see what happened when I try to do that right here. You can see this is where I put the peak, but there is not enough room left with all the rest of these steps for a real pointy looking peak right here. If instead I want to do this using the normal map, turn that one off, there we go. Oops. If I want to do that instead with the normal map, instead of having to add more on top, I just have to tell it to angle upwards at a really sharp angle, then angle back downwards at a really sharp angle, and I get this instead. Like that. If I want to take a look at my normals for this, it looks like this. I can angle up as much as I want, as high as I want, as many times as I want, and I will never, ever, ever run out of space. This is not going from 0 to 1. This is going tilt up, tilt down, as many times as I like. And so I want to see how these look here. This is the bump map attempt for the peak, and you can see I've got a little bit of a peak right here, but then it flattens out because there just isn't enough room for it. But if I look at the normal map, there's the peak. It's a bit exaggerated, but that's because I made it exaggerated. And I could do that as many times as I wanted anywhere on this model, anywhere on this map. And that is why normals are superior to bump maps.